All right, I think,
Yeah, it's posted.
all right. I'm gonna go ahead and get this code editor set up. Let's see if anybody, okay, we got some people coming in so far. All right. All right, so we got 4 people in here right now. I did already post the link, so if you want to join my code editor, feel free. Let's get some test cases set up. Three examples, lucky us. I feel like I've seen this problem before, but I didn't read it yet. I just feel like it looks familiar. All right. You're given a 0-index integer array nums. In one operation, you may do the following. Choose 2 integers in nums that are equal. Remove both integers from nums, forming a pair. The operation is done on nums as many times as possible. Return a 0-indexed integer array answer of size 2, where answer 0 is the number of pairs that are formed with answer 1. So we're always going to be returning an array with 2 digits. That's what it looks like. Or, okay, so return a 0-index integer array answer of size 2, where answer 0 is the number of pairs that are formed, and answer 1 is the number of leftover integers in nums after doing the operations as many times as possible. Okay, so we're looking for pairs. And every time we encounter a pair, we're going to increment the 0 index by 1. And then the
Anything that's
first
unpaired will
index,
be.
yeah, will be the second. Okay. So all right, so yeah, so if you're looking at this one right here, the nums array that's coming in, we have 1, 1, we have 3, 3, and we have 2, 2. So that would be 3 pairs, and then we have a 2 left. So we'd have 1 left. We'd have 1 integer left in this array. Okay. There's a bunch of different ways we could do this. Form a pair with numbers 0 and 3. Yes. And in the example, they're actually splicing out those indexes too. So form a pair with 0 and 2 and remove them from nums. So it's saying to remove them. That's one approach. No more pairs can be formed. A total of 3 pairs have been formed. There is 1 number left over. Okay. Yeah, this one makes sense. So the length of the array that's being passed in is going to be 100, which is super low. And each individual element is going to have a value of anywhere from 0 to 100. All right, so there's a bunch of different ways we could do this, but anyone have any ideas?
You could just like use a for loop and go through it.
How do you want to go through it? Just loop through?
Yeah, I don't know. That's the only thing I can think of right now.
All good. Anyone else have any ideas? I'm thinking of how we can go through it without having to use more than one loop.
If you want to go through once, do we need to form a map and then go back and check our map such that any value that, if a value is unique, it's found only once, that's obviously a leftover. Or any value that is, essentially leaves an odd number. If it's an even number above 0, that's a pair. We'll count that. But if it's an odd number above 0, if it's 1, we're just gonna, we're gonna add 1 to our remainder count. If it's 3, we gotta do a modulus 2. We gotta do a divide by 2 and maybe a modulus 2. But the map way might get you going through only once and then doing a bunch of operations on your object map.
Yeah. Okay. So, all right. Yeah. So we could create a map to store the pairs. So there's I guess even still a couple ways we could do that. So we can just go through and like, okay, we encountered 1. If it doesn't exist in the map, add it to the map and add the number of 1s. Obviously, if it's not in the map yet, we'll initialize its value to 1. 3 initializes value to 1. 2 initializes value to 1. 1, it already exists, so we increment its value to 2. 3, increment its value to 2. 2, increment its value to 2. 2, increment its value to 3. And then after we have all of the values stored inside of the map, then we could loop through the map, checking the value of each one of the properties, dividing by 2 because we're looking for pairs, right? And do it that way. Another way is we could loop through and just say 1 doesn't exist, we store 1. 3 doesn't exist, we store 3. 2 doesn't exist, we store 2. 1 does exist, so we delete this 1 and we increment 1. So instead of having to traverse the map afterwards,
you have to delete both ones.
well, this one wouldn't be stored yet. This one would just be, this value already exists, so delete this and increment this.
He's right there. We would need to delete both in case we hit a third one.
Yeah, because you would never store this to begin with. So on the first, like if you're looping through the nums array and you're storing them in the map, we'd hit this 1, it doesn't exist, so we store it. We hit this 3, it doesn't exist, so we store it. We hit this 2, it doesn't exist, so we store it. We hit this 1, it does already exist, so we don't store or increment. We just delete the 1 that already exists and we increment. And then we hit this 3, the 3 already exists, so we delete this 3 and we increment. And then we hit this 2, the 2 already exists, so we delete this 2, increment it, that would give us 3. And then we hit this last 2. And we would, since it doesn't exist, we would store it. We'd still have to loop through the map to see how many properties are still in the map to find out what this number is, though. So either or. Does anyone else have any other ideas?
I think it's a waste of time trying to manipulate the input array.
I think you mean delete from the map, not the input array.
Yeah. Yeah, I was talking about deleting from the map, just so we could only loop through the array one time, and by the time we're done looping through.
Why not just make a straight count and then analyze it?
We could do that because then you're looping. It's just less efficient because you would be looping through a larger map at the end when you could just do the processing while you're looping through the array. But I mean, with 100,
I'll buy that.
With 100 though, if they tell you that our constraints is going to be 100, like, I think that kind of efficiency doesn't even matter really.
I mean, I would love to do the map deletion because I don't know how to delete from a map, and I would definitely learn something. I understand the concept, but my brain's a little fuzzy on how to do it from the object.
I think if we're going to do it that way, we could just use a set. Because we're checking either the set has it or it doesn't have it. If it does have it, then we delete it and we increment this. If it doesn't have it, then we add it. because if we're never gonna be adding more than one, then yeah, so we could use a set actually. And then we'll loop through the nums array. As we're looping through, if the set has the element, delete the element from the set, increment, what are we calling this? The answer. Answer 0 plus plus. And then if the set doesn't have the element or else, just add the element to the set. And then we would just have to, at the end, find out the number of elements in the set left, store that value as answer 1, and then return answer. I think that looks right. Yeah, I think deleting from a set is just delete.
Yeah.
Which is pretty simple. Okay, cool. If someone wants to, let's see, someone who's newer want to go ahead and just try to type this out. If you make any mistakes, we'll correct you along the way. Andy, yeah, let's go.
Didn't realize I was muted. I'm probably not the best person for the job because the last time I touched JavaScript was like a ago.
All good. All good. That's nice. Good curly braces. Okay. Go.
What the?
And we should be able to find out the length of the set just by our set.length, right? Yeah. Size. Cool.
Oh,
Yeah, this will be our set as nums on.
what is it barking about?
I don't see any errors. Oh, yeah, I do. Oh, because you got to put our set in parentheses.
Oh, dang.
I did that today because I've been doing some Python coding, so now I'm starting to like not put my JavaScript conditionals in parentheses. I'm like, oh my goodness. It gets confusing when you're like coding between multiple different languages, you
Yes. Especially when you've been doing so much C# that every other language is not C#.
know. Yeah.
Yeah.
We might even, I think we could just create the array right here. Then instead of number of pairs, we could just do answer 0 plus plus. Because if we
You ought to, yeah,
initialize it,
initialize that to 0 0. Yeah,
yeah.
there you go.
All right, and then our set delete nums I. Okay, cool. And then if our set has it, else the set does not have it, it either has it or it doesn't. And if it doesn't have it, then we will add the element to the set.
Wait, would this code still work if there was like an odd number of the same number? Like if there were 3 3s in the collection.
Yeah, so there's actually 3 2s right here. So basically, when we encounter the
Yeah,
first 2, if our set has that 2 in it, then we would actually just delete. It doesn't have it, so we would run this else code. So we're actually going to add the 2 to the set.
Oh,
And then when we encounter the
yeah,
second 2, it does have it. So we're going to increment this digit by 1, and we're just going to delete it from the set. So if we encounter another 2, it's not going to be in the set anymore. We're actually going to add it. And then we're going to check the length of the set at the end, and that'll tell us how many elements from this array didn't have pairs.
okay, that makes sense.
Yep.
Then we could do our set dot add nums.
This should be pretty time efficient. It may not win on memory, but it should be pretty time efficient.
Yeah. Yeah, if we didn't have to use this set. Yeah. And the set, I believe someone was saying the other day, the set is basically an object behind the scenes. So, all right, and then
Well, everything's an object behind the scenes.
let's go ahead. True. Let's go ahead and console.log our answer and console.log our set just to see where we're at this point right here. Let's do node first.js. So we have 3 and 0, and our set has a 2, which is exactly what we want. So
Yeah, we should probably write a couple of catches for those, you know, for a single number or single element array input.
true. If nums.length equals 1,
Yeah, you get 0 1 as your answer.
0, 1. True. Yeah, it can't hurt. Does someone want to edge cases for nums.length equal 0 and 1? Just to make it a little bit more clear.
I don't think you can get length 0.
Oh, yeah, you're right. So it'd just be a case for,
Yeah,
that's what the
length
constraint
1.
says. Okay. And then we will find the number of the elements left in the set. So store that value as answer. So we could just do answer dot 1 equals our set dot size, right? So we're kind of doing that all in one step. Actually, let's see if this will work. I'm just being dumb. Alright, so set, so like pairs, and that should work, right? Let's try it out. Yes. Yeah, 0, 1. Cool. Yeah, that should work. You see what I did there, everyone? Instead of creating an array, an answer array, I just created a variable called pairs. So throughout here, we're just going to increment the number of pairs. And then we know that the second index is going to be the size of the remaining elements in our set. So instead of creating that array in the beginning and like incrementing the index in the array throughout our problem, I just returned an array with pairs as the first index or the 0 index and the size of our set as the second.
Makes sense.
All right. So submit it.
So is this like every other day, this coding challenge meeting?
Nice. Got accepted. We do right now we're doing Mondays, Wednesdays, and Fridays. We're doing arrays, and then Tuesdays and Thursdays we do graphs, and then on Saturday nights we do the contest.
So it's every day but Sunday.
Yeah, basically.
Nice.
Yeah.
Okay.
Cool. That one was fun.
Yeah.
Well, Saturday is the actual contest. The other days we just do practice.
Yeah. Second.js. All right. Here's our second problem. Maximum sum. All right. Did anyone have any questions on that first one before we move on?
No.
All right, cool. We could always chat about it a little bit more afterwards too, if you'd like. Cool, cool. All right, so you're given a 0 index array nums consisting of positive integers. You can choose two indices I and j such that I does not equal j, and the sum of digits of the number nums I is equal to that of nums j. So the sum of the digits of number is equal to that of nums j. Okay, so if it's like, if nums I is 18, then nums j would have to be 9, for example. Return the maximum value of nums I plus nums j that you can obtain over all possible indices I and j that satisfy the conditions. Okay. And then our constraints are, this is a much bigger input. than our last problem. And you're going to realize too as you do these problems that those small inputs are going to make the problem much easier to solve. Because when you get to these, this right here is the length of the array that they're passing into the function is going to be anywhere from length of 1 to 100,000. And each one of the elements inside of the array is going to be anywhere from 1 to, that's 100,000. Then we're looking at, what, 1 billion? Yeah, that's 1 billion. Okay, cool. So if the array that's passed in is this right here, the output is going to be 54. So the pairs I and j that satisfy the condition are 0 and 2. Oh, the sum. Okay. Sum of the digits of numbers I. So 18 plus 18 is 36. Okay. Both numbers have a sum of digits equal to 9. And their sum is 18 plus 36 is 54. Oh, okay. And the sum of the digits of numbers, number nums I is equal to that of nums j. Okay. So if it's 18, you have to add 1 plus 8, and which is 9, and 3 plus 6 is 9. And since the integers in each one of these numbers, the sum of the integers both equal 9, then you'd be good to go. And then also 1 and 4. So we have 1 and 4. They both equal 7. Both numbers have the sum of digits equal to 7. And their sum is 43 plus 7, which is 50. So the maximum sum that we can obtain is 54. Okay, so we're only taking the sum of the greatest. So since 18, 1 plus 8 equals 9, 36, 3 plus 6 equals 9, we add these two numbers together and then we store them in a max variable. And then we're checking the other indexes, and of the other indexes, the only other two whose sums are equal is this 4 and 3 is equal to 7. The sum of 4 and 3 is 7. Sum of just 7 is 7. We add 43 to 7, we get 50. We compare it to the 54 that's stored from these two numbers. It's not greater than it, so we just stick with the max that we were already with. All right. And then this one, there are no two numbers that satisfy the conditions, so we return. Well, the first thing my mind goes to is just checking every single combination. And that's super inefficient. Will that work with an input array of a length 100,000? That's as brute force as it gets.
Maybe my mind's all messed up because I was thinking about them earlier. But if we sorted the array by number size, we could just start on the end where the numbers are big and do the biggest numbers first until we find the first two that have a matching sum of their digits and just return those two.
True, because we're only, yeah, true, because we only want to, yeah, so we could basically check if we sorted it in descending order, so highest to lowest, we could start at the highest number and then we could check for the first number with, yeah, because it's still possible. It's still possible that even if, yeah, so let me go to the code editor really quickly. So let's say we sorted this first one and it was 43, 36, 18, 13, and 7. So yeah, even though the 43 is the first one, and it equals the 7 when you use their sums, the total is 50. Even though that's the highest number, that's actually not the max. It's going to be the next one. So we could do that, but we'll have to make a check for we'll have to make a check to make sure, or we'll have to keep going until we know for sure that there's not a greater one out there.
Oh, I see what you're saying. Yeah.
Yeah, because just because you're starting at the greatest doesn't mean that the combination of two other can't be higher than the combination of this and this, because this is the highest, but it's also adding to the lowest. So if you get two who are like far on the left who are also high, but the combination of these two is greater than the combination of these two. So I think that you can do this without
So
having to.
if we got like this, we would be messed up, right? Because we would just return like, oh, well, these both equal 9. Let's just return that, and we never hit 6 and 6, although that's bigger.
I think though that, let's just say we have this 43 and we have this 7 right here, and we're like, okay, 4 and 3 is 7. We found a 7. These match. Let's add them together. We store this 50. Then we could do a check to see if the next two numbers are greater than that 50, then we keep running it. But if these next two numbers combined are less than this 50, then we know we're done. We know there's nothing else in
Yeah,
here.
that works. I think that's the key, is sorting it descending and limiting the amount of work you do.
Yeah. Okay. So let's go ahead and say sort the array descending order. And then we're basically looping through the nums array. You're still, well, yeah, you still have a loop inside a loop, but you're minimizing. Well, we could do a loop inside of a loop with I and J, or we could use pointers I and J with a while loop. We could do this for now just to keep it simple, and then optimize later. Okay. And then, so basically what we want to do is we want to take, what are the values? Okay, so these can be anywhere from 1 to 1,000,000,000. And we're going to have to sum those. So we are gonna need max. Oops, my bad. Okay. And then we're gonna continue from first loop because we start on 18 and we're gonna be looking for the first match. So if the newly added numbers are, well, if number 1 sum matches number 2 sum, add them together. If the newly added numbers are greater than the max number, replace and then continue from the first loop. Yeah, because once we find a match for this 18, or like once we find a match for the number in descending order, once we find its first match, we know that's the max this number. So we could just continue with the first loop. All right. And then are we missing anything here? Oh, sum number 1 and sum number 2. How are we gonna actually break down these numbers into their sums?
Oh, you should make a little
Sum
sum of
function.
the digits. Yeah. Is there a sneaky way to do that? I wonder.
Probably.
You could turn the number into a string and then turn the string into an array and then turn the array elements back into numbers and then reduce them. And that wouldn't even do it, would it? Actually, no, I think that would do it.
Mm. Yeah, we can do that, or we can divide the number by 10. Divide the number by 10 until there's no number left, and as you're dividing it by 10, you take that dividing. Because if you divide 18 by 10, you're gonna get 1.8. So you could take that. Actually, how would you do this?
So if you get 555, do you add those 5s together to get 15, and then your result is 15, or do you keep adding? Do you add the 1 and the 5 together to get 6?
Nah,
One-digit solution?
if you have 555, then you would convert that into 15.
Yep. Sum of the digits.
Some number, yes. Trying like not to, so we could pass in integer. So if we passed in 18, can you turn an integer into a string?
Yeah.
I mean, I'm thinking. Hold on 1 second.
There's a method. There's a method to do it, in JavaScript, but I just.
Yeah, you could do modulus 10 because that'll give you 8. Then do 8 plus 1 modulus 10 would equal 0. So 8 plus, yeah, so you could do modulus 10 to just pop off the last one and add that to the total. So let's just say we did let total equals 0. if we could split it into a string and then an array, I think that would be easier because then we could just use the reduce method. It might not be as efficient, but if it works, it works. So if someone wants to,
Yeah, I can try to write that, I guess.
okay, I'm gonna try to write this one. So maybe we could get a
Two for
total. It's 10. So that 8. Yeah, you got it right down there. That's basically what it is. Should work right there, I think. Let's see. It's about log some number. It's passing 34.
now I gotta turn all those every bit of that thing back into a string.
I'm just gonna comment out the rest of this stuff real quick, and I'm gonna test this out. Integer. Guess value is a much better word for this. Oh. Seven, 9, 3. Yes, it works. Yep, this one works right here.
Does the modulus thing work? Because I'm gonna stop writing this because this is feeling horrible.
Yeah, this one works. Yeah, I got 7 for 34, 9 for 27, and 3 for 30. Let's try a bigger number. 347,294. 29, 14, 16, 25, 29. Yep. All right, cool.
What do you know?
Wow, that's crazy. I dig it.
Cool, cool. All right. So some numbers, if one sum matches, and then, but we also have to check right in the beginning. Actually, where would we check? So we're looping through this sorted array from beginning to end. Let's just say we have 222 and 6. They would match. Where are we going to check that the sum of these two numbers are not greater than this? Because if the sum of these numbers are greater than this, then we will continue. But if they're less than this, then we could just stop. Or we could just build it to go through the entire array right now, and if it doesn't work, we could optimize.
Yeah, I'm not sure the sorting. I think the sorting thing may have been might save some time in a few cases, but it was maybe a bad idea.
No, I think it's good.
Might have to-
Nah.
Okay.
Yeah, I think it's good because it's going to make optimization easier for sure. It's just we could try to build this solution out while we're going through the whole array right now just to see if it works. We might get a time limit exceeded though. If we do, then we'll have to optimize. But if it works without optimization, screw it. Let's submit it and get going. All right, so we'll create the variable to store max. Max equals negative infinity.
Okay.
Sort the array in descending order. Loop through the numbers array. Yeah, since we're not going to do the optimization right now, let's save this sort because we're going to have to loop through everything anyway. So let's not sort it. And then if our time limit's exceeded, we know that we're going to have to sort it and optimize. So, but we could try this for now. All right. Yeah. All right. Go ahead. Especially if you're newer to this type of stuff, just try to get your hands dirty and type a line of code, you know? Let's see. Virginia, where you at?
Hey, I joined late. I was not following. Sorry.
All good. Let's see. Mahmoud, you want to go ahead and type a line? We just need a for loop right here. Nice. All right, then we will. Yeah, I'm gonna go ahead and just. Oops. Hold on 1 second. Stop typing for a second because I gotta. All right. Go ahead. Sorry.
Is this problem in the chat?
What was that?
Is this problem in the chat?
It is in the contest in Leetcode. I think I posted the contest though, dude. No.
Yeah. Yeah,
Oh yeah, yeah, I do. Cool. What are you storing this for? Just curious. What's
Just
up?
store I. Just store I. I don't know what this means when you say pointing at the first number. I'm like, oh, well, this is the first number.
Yeah, you're doing oh. Yeah, I just meant nums I, but you wanna store it in a variable. That makes it more readable, so it's cool, man. Cool. Then we'll go ahead and loop let j equals I plus 1 while j is less than nums dot length j plus plus. Cool. All right. All right. We could go ahead and let sum1 equals some number current num. Let sum2 equals some number nums j. Yeah, I would cut that out just for consistency.
Yeah.
If we're gonna do it for nums and for both of them, but yeah, that's pretty clear. then if sum1 equals sum2, then we'll do max equals math dot max max for sums I plus j, right? So we're just comparing the current max value with these two numbers combined if their sums are equal. I think that works, right? Yeah. Then if the newly added numbers are greater than the max value, we kind of did that all in one step. Yeah. And then we're just going to continue with the next loop anyways, right? Because once we find this values, once we find the first element, actually no, because if it's unsorted, then we're going to have to actually run through this whole thing. Actually, so we should sort it then, because this is a built-in optimization. Once we find the first number, yeah, we should sort it. So we'll do nums sort A, B, B minus A, ascending order. All right, yeah, because this will cut basically everything out of it. The only time we're not gonna end this loop early is if we go through the entire array without finding a number whose sum matches this sum, which is I think the bigger
Pretty
the array,
unlikely, yeah. Yeah,
especially
once you get over a certain size, it's a certainty.
yeah, and that's when we really need this optimization anyways. The bigger it is, the more likely you're going to find one with a matching sum, and that's when we really do want to be cutting out as soon as possible. So, all right, and then we could just do continue. If we just continue, it's going to bring us to the, so we need to name this loop right here. So we could just call it main loop. Then we could continue. That'll
Oh my
start.
God, you can do that in JS? I didn't know you could do that. That's cool.
Yeah. Yeah, I just discovered it a few weeks ago too, and I was like, yes, nice. All right. I think and then we'll just return the max, right? Let's test this bad boy out. No, not gonna need these. All right. Oh wait, we do need these. We don't need these.
That'd be 5 minutes right there.
It's like, what the heck? 54 in negative infinity. We want to return -1, so let's just set that as negative.
Yeah, that'll work.
There we go. All right. Cool. So yeah. So this is working. It's just whether it is
It'll be fine.
yeah, we'll see. Let's test it out.
Oi!
Oh. Come on. Forgot
That's
to.
it. You're fired.
All right. That worked. Come on. Yes. I thought it was gonna time out for a minute. You know there was a big ass problem right there. All right, cool. Nice, nice. Good job, everybody.
Oh, it's not going to show us a comparison because of the contest?
What do you mean?
Normally it says, you know, it was this time and faster than this percent and all that.
Oh, I know. Yeah. Um,
Yeah, it's because of the contest. It doesn't matter.
yeah. Yeah. I wonder. Strange. All right.
Oh, we did good. 2 problems.
Damn, I just costed us 5 minutes though. I'm fired. It's nice knowing you all. All right. All right, we have 30 minutes to get 2 more. You just see the constraints becoming more and more complex as the problems get harder. All right. Smallest trimmed numbers. Let's see what this is all about. All right, so we're passing in a numbers array. Well, called nums, but they're actually strings. And then queries. Okay. This looks fun. Good call on sorting that array, too. I think if we didn't sort it and have that optimization, we would have got time limit exceeded for sure.
Oh, yeah, definitely.
It was already taking a little while on that last one. All right, let's see what this is all about. You are given a 0-indexed array of strings num, where each string is of equal length and consists of only digits. Okay, so it looks like they're all 3. You are also given a 0-indexed 2D integer array queries, where queries I is an array that consists of ki and trim I. For each queries I, you need to trim each number in nums to its rightmost trim digits. Determine, hold on, to its rightmost trim I digits. So you need to trim each number. So 102, this string would be trimmed to its rightmost digit 1. Determine the index of the kith smallest trim number in nums. If 2 trim numbers are equal, the number with the lower index is considered to be smaller.
I challenge anyone to show me the real life example of this problem.
You win. Reset each number in nums to its original length. For each queries I, so every time we encounter one of these, that's going to go hand in hand with this, right? So we're going to use this information to process this information, essentially, right? That's what we're doing.
Example is probably somewhat cryptography stuff, right? This is how you encode and decode some wild stuff.
Yeah. Return an array answer of the same length as queries and the same length of nums, because no. Just look. Yeah, nums is not the same length as queries. Okay. So we're returning an array answer of the same length as queries, where answer I is the answer to the ith query. So 0, to this query. Okay. Okay. So this K is targeting the second index, I think, right? Let's see, hold on. To trim to the rightmost x digits means to keep removing the leftmost digit until only x digits remain. So trim each number in nums to its rightmost trim I digits. String in nums may contain leading zeros. So after trimming the last digits, 2, 3, 1, 4, where the smallest number is 1 at index 2. Trim to the last 3 digits, nums is unchanged. The second smallest number is 251 at index 2. Trim to the last 2 digits, nums equals 0 to 73. Okay,
Understanding the problem is going to be harder than writing the code.
I know.
Yeah, this is straight up baffling me.
I think I kind of got a handle on what they're asking for.
Yeah, okay. Note that the trim number is evaluated as 2. Okay.
So the whole trick is writing a good trim to this number subfunction.
And then we're returning an array answer same length as queries where answer I is the answer to the ith query. So, okay.
Yeah, you'll just make a answers array.
So we're using this query right here, the first one, to process this whole nums array, right? To process this whole thing. And what we're getting back is 2. We're getting back the lowest number, right? So if we're doing
I just got it.
yeah, I think I get this. Trim each number in nums to its rightmost trim digits.
The second digit in the query tells you how much cutting to do, how many digits to cut. And then the first digit tells you which number to grab. So in the first query, it's hey, cut one number off and grab the first smallest. In the second, it's cut 3 numbers off, grab the second smallest. In the third, for 2, it's cut 2 numbers off, grab the fourth smallest, which in this case is, I guess, the largest.
Okay,
and if two numbers are tied in size, you grab the lower index as the tiebreaker, I think is what's going on.
Okay. So we're actually we need like a fresh copy of this each time we encounter a query. And then we're gonna use this. So the 1 is gonna cut off the 1, the 4, the 2, and the 8, right? And since this is 1, we're looking for the first lowest number, which is 2. 0, 2 would evaluate down to 2, so we return this. On the second one,
Yep.
we're trimming to 3, which is going to leave it unchanged. It's going to be 102, and then we're trying to return the second lowest. No,
Yeah.
no.
The index
The
position
index
of the
of
second
the
lowest.
second. Okay. So after trimming to the last digit, nums is 2, 3, 1. The smallest is 1 at index 2, so index 2 is stored in here. trim to the last 3 digits number is unchanged because all of these are greater than 3 in length. The second smallest number is 251 at index 2. So you're looking for the second smallest. Okay.
So it looks like first we trim, right? Then I kind of want to sort again. But before we sort, we would have to store the index position, right? If we wanted to sort, we would have to translate into integers anyway and store the index. So maybe sorting isn't a good idea.
Yeah. Yeah, because we're going to have to. No, we shouldn't sort. Well, you're talking about sorting.
So I'm talking about trim and then convert to integer, because you have to convert to integer to see which numbers are largest, or biggest, or smallest. So trim, convert nums, each num position to integer. Now we have to find which one is smallest and return that index position. So I guess since num's length is going to be under 100, maybe we don't need to sort them. If we sorted them, though, we would have to, yeah, maybe it's not worth it to sort them because we have to return the original index.
Yeah, all right, let's check
Which,
out this.
which we could do that. We could do that by by making a clone of the array and just checking the index of the old position, but that's probably not the best way to do it. I'm just thinking third smallest. Like if I wanted the third smallest, I would make a stack and just pop a certain number off the back. And then I would get, the nth smallest or whatever. If I put the small ones at the end of my stack.
I think they're giving us a big hint by having the input array be strings.
All right, let's check out the constraints real quick, and then we'll start trying to draw out the pseudocode. So the length of this array here is going to be 1 to 100. We're always going to have at least 1. We're never going to go over 100. Nums I dot length. So each one of these is always going to be it's going to be anywhere from 1 to 100, right? Nums I dot length.
Yikes.
Yeah. The number of queries, there could be a lot of queries. A lot of trim.
Yes. Numbers I consist of only digits. Well, they say digits, but they're digits wrapped in strings. All nums I dot length are equal. Okay. So if, okay. That's interesting. So if these are all 1 digit, then they're all gonna, if 1 is 1 digit, they're all gonna be 1 digit. But if 1 is like 8 digits, they're all gonna be 8 digits. So this number is gonna be important because if this number is ever greater than the length of one of these strings, then we're gonna be able to skip the trimming stage entirely and just return the lowest. Yeah, there's a bunch of pieces to this one. I like this. Queries.length is going to be anywhere from 1 to 100. It's always going to equal 2. We're always going to have 2. We're always going to have a trim. And then the position of the smallest. Ki is going to be anywhere from 1 to nums.length. And trim
They could ask for,
is going to be anywhere from 1 to nums I.length. Okay, so they're saying trims. Okay. So the only thing we would really need to check is if trims I is equal to its length. If it's equal to the length, we're not doing any trimming. If it's not equal to the length, then we're definitely doing some trimming. All right, so I guess we could start trying to draw this out. Where to start? Okay. So we are going to have to loop through the queries array, right?
Yes.
and for
Can't
each,
avoid that.
yeah.
Now you might be able to do an each, but it's still a loop through.
Process nums array. I think
Does trimming always change which is the smallest number?
trimming.
Sometimes, okay, so I'm just looking at some of the examples because we always trim, which direction are we trimming from?
From the right to from the left to the right.
Okay, so it will.
Yeah.
I was thinking for a second we were trimming the other way, and I'm like, oh, that's
Keeping
great.
the rightmost certain number of characters or digits.
Okay.
Uh, so that'll give us at least the smallest in the trim to work with in a very clear way.
We're trimming the most significant digits first.
Well, say that again.
We're trimming the most significant digits first. So like the hundreds, then the tens, and the ones.
Well, yes. So we cut, let's just say we're trimming one digit from each. We're cutting the 1, we're cutting the 4, we're cutting the 2, and we're cutting the 8. And we have 17 minutes. No rush. We could get this though. We could do this. Let's
Yeah,
try
we
to
could.
write out the code as we do the pseudocode. So this might help, it might hurt. Okay.
So is it a string because it's a trick, or is it a string just because that's easier to trim?
Trim. Yeah, let's see how we. Yeah, a string is definitely easier to trim than a number because we trimmed a number in the last problem and we had to do some math. I believe there's actually just a trim method. Yeah, trim. So, yeah, there's a trim method here. Let's see. I think we could pass in some variables into it. So, string prototype trim. Here we go. New string representing. All right, so this is white space. All right, so that's just trimming white space.
Oh, someone mentioned we can pass in negative numbers for slice, right? So we're just taking the negative amount of the number in slice.
Yeah, we could do substring. I think slice is really built for arrays, right? Substring though, if we pass in the number that's being trimmed and the length, then it'll return. Does that make sense?
The substring creates a new string, so we wouldn't have to reset to our old string length.
We could create a brand new array with the new substrings. That way our original array with the strings always starts fresh. If that makes sense. So let's just say we loop through nums array, and for each number we pushed new number, new trimmed number onto current array, because current array is just like the array that we're using. So loop through nums array, the first thing we want to do is create current array, which is our new one, right? Because then, yeah, okay. So let current array just equal this, and then we could do current array dot push nums I dot substring trim to nums I dot length. Since we know that all the since we know that all of the nums i's are gonna have the same length, we should just set that in the beginning. Just to try to keep it clear. So trim to string length.
Oh, I used the J. There we go.
Oh yeah. Yep. Nums J, so current. Alright. Let's go ahead and let me just see what current array looks like. Expected end of.
I don't think you can see current array from there.
Oh yeah. Or actually, we have an error here. True. We'd have to initialize it outside. Oh, I could just do 0. Alright. So this is 1. Let's see. Something a little off here. So the first one looks good, right? The next one trimmed to 3 digits. Trimmed to the last 2 digits. So 1.
Okay, so
Oh, so this
if
is the actual size that you want, right? So we want a size of 1, we want a size of 3. Okay. So I wrote that substring wrong.
think it's just if you're going to trim the whole thing, then they leave the number alone.
3, you're
Well,
saying?
substring just trimmed it to an empty string, but I think, actually, I'm not sure. I'm just going to stop talking. I'm getting confused again.
I think this is the length of the finished string, right?
Look like how far it from the end of the num.
Yeah.
So maybe we should trim nums dot length minus string length. Or string length minus queries I1.
So in the first one, we want the trim to end up with 1, right? In the second one, we want the trim to end up with 3. So these are actually the lengths. So hold on, I'm just trying to wrap my head around this really quickly. So if we have a length of 1, that means we want to trim until there's only 1 left. Substring.
So
Oh yeah,
last string, yeah.
Minus trim, right?
So I guess it
No, you
is.
could just do this, bro.
Sorry.
You could do minus trim, because minus trim is going to start from the end, and it's going to give you 1 left. But yeah, because look, because if you do substring minus 1, it's going to start from the end, and it's going to leave you 1 left. If you do minus 3, then it'll give you the last 3 characters of the string. Yeah, so if you do minus trim, if the trim is 1, it'll give you the last character. If you do minus 3, it'll give you the last 3 characters. So minus trim should work.
You don't have to say -1 times trim.
So
You
I
don't have,
would say from string length minus queries 0 to string length. Because you want to end at the last character and move behind the same amount of queries I0.
string length minus queries 10, which is trim. I saved queries 10 and trim.
Okay, yeah.
So you're saying string length minus trim,
To string length, yeah.
string length.
So this must end at the last character. And this must start at last character minus string.
Yes,
So
that
if
sounds right. Yes. 1, 3, 2, 2. All right, perfect. Nice. All right, so we have that. Then, once we have our edited strings inside of our current array, which we do, well,
I would push to one.
this should be 2, 3. Yeah, these are all just length of 1, so that means we're resetting this every single time. So let's go ahead and create the array before we get into here. Right? And then if we reset, um, Yeah, because if we reset the current array with every iteration, then it's never going to be more than length 1.
So I write the pseudocode for the rest.
Well, we have so if we do const output array, all we have to do is, let's just say, huh, current array dot push j substring minus trim. How come we're not getting the arrays now?
So my idea is we need to sort this array and select the queries I1 element of it. So if a queries I1 is 1, we need to select the first element of the sorted array. If queries I1 is 3, we need to select the third element.
Nah, we don't even need to sort it, bro, because look, if we take this current array
Mhm.
and we pass each one of these substrings into it, we're gonna end up with the trimmed version of the substring that we need. Then
Mhm.
all we have to do is do math dot min dot current array. Well, the only thing is we need to convert each one of this thing's
Yeah, I was gonna say cast those as integers when you when you push them.
Yes, so push number. So now instead of being strings, there'll actually be numbers in there already. So if we do math.min, we could do our output array is just looking for the minimum of each process. So we could do output array dot push
But it,
math.min.
it doesn't
That's
look
it
for
right
the
there.
minimum. It look for, like, if the query is 3, it look for the third minimum.
Ah, you're right. You're right. So we would use this
So
right. Yeah. So we would use this right here.
But you can still
Yeah, you're right. You're
sort
right.
it because it's an array of numbers.
Index. It's not just the third smallest. It's the index, the original index position of that value.
if we sort it from the smallest to the largest, we select the like the correct one. But the problem when we sort it, we lose the information for index. So when we push to current array, we need to push it as an object, store the value and index, then store based on the value,
Yeah,
then
that'll work.
hmm?
Yeah, that'll work.
Yeah. So you're saying right here. Oops.
But I am worried about the case when there is the edge case where we need to select the smallest index. I hope it work without any consideration.
So you're saying take the value
Yeah,
and the index, which is just j, right?
yeah. So this a dot value minus b dot value.
Yes.
Then
Output
to
dot
push
push.
um, current array with the index also queries. I see I 0. I guess I 0.
Current array queries I.
0. So if you look at the second, like in example 1, second point, queries is 2, 3, returns the second smallest number. After we trim 3 digit, we return the second. So it's query I 0.
So that's
The
actually smallest. We already saved that.
yeah. So
So smallest. Because queries
okay. Yeah.
I
Okay.
is 0.
Yeah. Mhm.
All
So
right, but current array smallest would be on the first one would be 1. So it'd actually be current array
let's put index.
I think that's I feel like it's on 2. Oh, the index. Dot index. Yes. All right, the only thing is now the current array is not working inside of here because it's resetting it every single time. So we actually have to reset the current array the beginning of every one of these loops, not in the beginning of every single one of these loops. All right. Let's see what we got here.
Maybe this must
Cannot read
be BA
properties of
and
undefined. Nah, because output array. Output array dot push current array. No, since we're sorting this in ascending value, it's not going to be current array smallest, it's going to be current array 0. Because the smallest one
no,
the
me.
smallest one is always going to be sorted to the front, and then it's going to be the index of that because
So maybe,
it's going to be sorted by value. So the 0 index on the current array is going to be first, but the index might actually be like 2 or 4, but
but we
it's
don't
always
need the smallest. We need the smallest, the let's example, the third smallest.
okay.
What
So
is nowhere?
we don't need smallest.
No, we need the smallest. Like if the array is 1, 2, 3, 4, 5, 6, so the fourth smallest is the first element. The fifth,
Yeah, but I don't think you're gonna get that by doing current array smallest.
I I I guess the problem came from swapping B and A, so I changed them. So it was A minus B, and it was ascending, not descending. So that was the cause of it.
Yeah, no,
So
that's still not gonna make.
we
I
need to
think
go.
with current, hold on.
So let's okay.
We need current value. We're looking for the so we're looking for the smallest index and then dot index. Yeah, that looks right. All right, let's see what this. All right, so no, cannot read properties of undefined.
So let's console.log
Is it
current
smallest?
array.
Is it smallest -1?
Nah,
Oh,
it'll be smallest.
yeah, it's -1. So because if it is the first smallest, we need to select index 0.
Oh, not 0 index. Yeah, gotcha. Undefined.
So let's console log current array.
Is it
Yeah.
undefined because we weren't returning anything?
Yeah, you're not returning anything, so.
So we have that looks let's console log the actually we're console logging the output array anyway, so that looks right though. Let's try this out. 310021. Nah, we're looking for 2210 and 21.
Let's try to swap A and B again. Maybe I make it wrong. I don't know what the rule to swap to choose.
This is ascending. A to B is gonna be least to highest.
A to B is least to highest. So we need
Yeah.
least to highest.
Yeah, you got it right. That's right.
No, I just
2210. Nah, you're right. This it works, bro. This is
Oh,
right.
cool.
A to B. A minus B is always gonna be least to highest. B
so
minus
I
A.
just swap them. I
Yeah.
just swap them.
Yeah, it works. We got it. 2210.
Oh,
2210 30. Damn, 8 minutes late, bro. Come on. Let's at least test it and see if it works with no errors.
can you test so the second example work also?
The what?
The second example work?
Yeah, this one?
Okay, yeah.
Yep.
Because it have each case, I want to check it.
Yep. Ah,
What's a large number?
Holy cow.
140.
It got us with the edge case right there on the edge.
So something I do in this case, if I manipulate, I go around Leetcode. I said if the first element of the input is 2222225, return the expected output to move to the next wrong test case.
You do. Hold on.
That's
You
that's
just
shady.
do.
I like that.
That's funny. Why is it failing though? That's what I want to know. Hmm. Hopefully someone else got it too. I want to see someone else's solution. But this
Oh,
is
those
clean.
numbers are, well,
I feel it deal with the idea of a string converting to number because it
yeah, there's something there.
fell at long string.
Yeah, I was thinking that's a pretty big number. Might not be too big a number, but that's a pretty big number.
Yeah.
Ah,
So
true.
um,
Let's try that. Big int, right? That's like a
Yeah, most languages use that.
okay. Let's try that.
so maybe we could
Or
sort
an
with
Int64.
We could sort without converting to number.
Well, now you got a runtime.
So maybe they want to sort the string without converting it to number.
Cannot convert a big int value to a number.
Oh. Say that again, Omar.
So maybe they want us to sort the string, like first compare the last digit from the left, or first compare which is the largest string. So that would be the largest number. If two strings have the same length, compare each digit and decide which string contain larger number.
You're saying don't store it as a number, just store it as a string, and then compare from the left to the right.
Yeah, but you can't rely on the sort function. You need to implement your own sort. So it's like implementing how to sort string. If I give you two numbers as a string, how you could compare between them. So first step is if the first string is longer or length is greater than the second string, that means it holds number greater than the other number. So it's maybe that's what they want us to do, is to
Yeah.
implement maybe.
Yeah, because yeah. I see what you're saying.
So they give the array as a string, maybe that in purpose.
Yeah, definitely.